Apparently, transcription has started itself. Hello, everyone. Welcome to yet another Visual C++ Open Code review. I'm Casey Carter, member of the libraries team here. I spent a lot of time working on the STL and quite a bit of time working on standardization with WG21 of the actual C++ language. Today, we're going to be talking about P2440R1 for the STL, which is implementing P2440R1, ranges iota, ranges shift left, and ranges shift right. I'm going to pull out the paper real quick since I didn't do that yet. Oh no. Sorry, I don't have my shortcuts configured correctly here. P2440. This is a relatively short paper, adding three.
You are not yet sharing your screen, by the way.
I'm not yet sharing my screen. Thank you. Okay. This is the paper, P2440R1. It adds three new ranges algorithms, things that were already existing algorithms in pre-ranges world, right? Iota exists, except it's not in the algorithms header, it's in the numerics header, but it's nonetheless an algorithm. This adds iota, shift left, and shift right as ranges algorithms in addition to their stood algorithm versions. So let's get the PR and the paper side by side. We'll go into the files here. All right, I'm going to do my usual alt-click trick to compress everything down. And wow, this is touching a lot of files for adding three algorithms. We've got a new test for each, test case, and configurations for test configuration. We've got to change to the feature test macro, presumably because this paper adds a feature test macro that we'll now need to test for. Changes to core, probably to show that the paper's been implemented. Interesting. Did we add ranges iota in the numeric header? We must have. That's news to me. I thought we were going to add them on algorithms, but I was apparently wrong. Yep. It even says the feature test macros in numeric. All right, awesome. It's more fun to discover these things as we go than to read the paper ahead of time, right? So now we know why that's changing all of these headers. Let's start from the top. Let's make sure the new tests are in here and that the names are spelled correctly. This is the shift left test, and both of its files are there. Shift right. Uh-oh. Oh no, this is a change to the existing shift right test. Now I'm very confused why we're changing the existing test and adding a new test. But we'll work that out when we get to it. Addition is actually correct, the correctly spelled name, and that's all I'm concerned about right now. Again, these three new tests have been added and the spelling of the names is correct. We actually have to double check that because otherwise our test automation isn't bright enough to tell us if the names are spelled incorrectly. It will just run no tests and be happy. Next step, let's pop into YVal's core. Yep, there's the addition of the comment that says we've implemented this proposal. It is in sorted order. I'm not sure if the name matches number 2537, the name in our issue. We're usually really sticklers about using a simplified name, 2350, simplified titles for papers that are easier to keep track of. That's not the right one. 537. Okay. to transposition. Yep, that's exactly the title we listed it with in our issue for the proposal. So that's all correct. Looks like we have pulled CPP lib shift out of the C++ 17 section of feature test macros, probably to move it down to the conditional section. I'm gonna make this bigger. Too many comments. 23 section. No, we've got this in the wrong place. Apparently, Stefan has already commented that this is the wrong place. It needs to move down to the macros with language mode sensitivity section. We have 4 different sections of feature test macros that we define here. There's C++ 17 macros, things that are defined in 20, things that were defined in 23. Whenever the macro depends on language mode or pretty much anything else, it gets pulled out and goes into a 4th section for the whatever configurable things. And this needs to go there, but isn't yet. So that's already noted. We don't need to note it again. We'll make sure that the value is right. 2022-02, which is the February meeting. I'll check that in now. That I conveniently have the working draft open for. CP lib shift is in fact defined to 2022-02. So this was added in February. We've got into comment that correctly matches the condition on the if. So that's all good. Addition of the new feature test macro for CPP lib ranges iota. This is out of order. It was added to the end of this section instead of being added into this section in sorted order, which would put it somewhere up here. In between invoking is scripted. Stefan has already commented on that.
It should actually move up just 1 because it's CPP lib ranges iota.
Thank you. So luckily I didn't comment it incorrectly and I don't have to fix it. Anyway, we have feature test macros. That's presumably all of them that were defined by the paper. I don't understand why people can't put the feature test macro wording in the right order. Like we never do. Update the value of CPP lib shift in version .sin. Define CPP lib ranges iota. Those are all the feature test macros. So this header has everything correct. Well, there's nothing additional to comment on in this header, I should say. They're all they've all been commented on. Moving on. Let's do product code. I'm going to look at X-utility first because it's a higher order header than algorithm or numeric that users include, right? This is an internal header. And this one happens to be included by both algorithm and numeric, so I assume there's a common code in here. And this is adding the out value result, algorithm result type. There are a whole bunch of these things that we call result types, whose names all end with underscore results, that were added to be types with pretty user spellable names for the return values of the ranges algorithms, because we wanted to avoid ever having anything return tuple or pair. We wanted to always return named types with named members that people could refer to that would be stable. Because it's very hard when you're writing fresh code that takes a pair, right? If you're using, say, insert into a std map, returns a pair of an iterator and a bool, and people can never remember if it's an iterator and a bool or a bool and an iterator. So having actual names means you don't have to remember the order. Anyway, this is called out value result, which means it's going to have a member named out and a member named value. We have a very, very simple naming rule that W21 uses for these types. These are going to have no unique address applied to them, which is pretty much a good idea with anything generic. In C++20, I'm going to go find, here's the declaration of this class template. It's supposed to be instant ranges. Make sure we're within ranges. Yes, we're within ranges. We're in the concept section. This is being made conditional for C++23, which is all correct. There's the indif. There's a comment there. It does match. The detailed specification of this, and I didn't want to click that. That's going to link to the standard. All right, detailed spec. This is again a class with 2 parameters. The members are both there. Their types are the first parameter, the first template argument, and the second template argument. There are no unique addressed appropriately. We are leaving these commented out in the STL for now because MSVC didn't support no unique address for a very long time. And what we did do was add the attribute to the compiler so the compiler understood the attribute and didn't do anything with it. And then by the time it came, by the time we decided we needed to actually implement the semantics of the attribute, it became clear that doing so would be an ABI break because we had been compiling code that had that attribute in it already for a couple of point releases and not doing anything with the attribute. Since we really, really don't like breaking ABI, that meant we decided to have no unique address do nothing in MSVC until the next ABI break. We do have another attribute that's in the MSVC namespace. It's MSVC : no unique address, which does it does have the semantic effect that the standard specifies for no unique address. Right, there are no backwards compatibility concerns because we added that with the semantic in place right when that attribute was new. But unfortunately, that means we still can't use no unique address even with the MSVC specific attribute in the STL because Clang doesn't support it yet. And Clang largely doesn't support it yet because they're waiting on me to get information to them about exactly how our implementation works, and I haven't had time to do that lately. So for now, we have no unique address with comments in many places in our header files as a reminder that eventually there needs to be a no unique address there or the equivalent. Okay, again, this is result type. They have the standard format. They have named fields in a struct, and they should be convertible to other specializations of the same class template when the types of the members are convertible from the types used in this specialization to the types in another specialization. So here is a conversion operator to out value result T with out and tie to. Interesting. I would expect to use the same convention, either adding 2 to both of the names or doubling the character at the beginning. I wouldn't care about a convention, but it's kind of strange that we picked 2 different conventions for naming these. So I'm going to comment on that. It's odd that we're using name adjustment and name adjustment conventions to get the parameter names for the conversion operators. Please pick one. I'm going to go ahead and edit this and point out that it applies to both. Oh,
Looking at other examples in the STL, it does appear that the repeated character is the current convention. We've got I in, O out, F fun.
I wonder if to tie was a problem. I can't imagine what it would be.
Interestingly, for like min-max result, we do use tie 2, so there's precedent for both, just not in the same type. Actually, maybe there is one. I haven't completely searched thoroughly yet.
Consistency is the hobgoblin of small minds, I think is what Einstein said. Anyway, we'll work that out. All right, so it's a conversion operator. It is correctly constrained to require that the target type, O out, is convertible from a const L value out, and that's going to be const L value because this is a const L value qualified conversion operator. And same for the other type, that const tie-ref is convertible. Sorry, that tie2 is convertible from const tie-ref. A little helper concept. And of course, it just has to return members. Yes, this is an aggregate. It's not it's an aggregate. We don't need to worry about explicit conversions. So it doesn't need to name the target type. The other one, this is going to be the R value converting constructor. Yep. It's R value qualified. And we require that R value out, sorry, an X value out, I guess. Right, that out is convertible from an out X value. The ref here is extraneous. This is one of those things that we like to harp on a lot in the code. With type traits and or concepts that use declval essentially in their implementation. The T-ref is the same as T, right, is equivalent. And we try to keep the excess the extraneous refs out of the code because it's just a little more garbage to read and decipher. Someone has already commented this, so I won't comment it again. Thank you, Misco, for catching that. Otherwise, this is a const expert conversion operator to out value result of those types. Once again, we're returning, the only difference here being that we're moving these members to get conversions from R values, which is consistent with the R value qualification of the conversion operator. All good. So this is matching the pattern that we use elsewhere for a great many algorithm result types. And that's the only change we have here in X utility. Yeah. Presumably that's going to be used in at least one or two of these. It's also possible that they just put it in the header. No, uses out value result. Or sorry, I'm going to scan through quickly. No, these return subrange. So it's actually only going to be used in numeric. But presumably someday we might add another algorithm that needs it, and it might make sense for it to be an X utility instead of pushing it down into.
Uh-oh, it looks like we lost Casey.
I'll go poke
I
him.
guess. Okay. Maybe his team's crashed. Please stand by.
Hello, welcome to another Visual C++ open code review. Okay, where was I when I disconnected?
You were talking about potentially moving something to find an X utility down to the header it's used, or whether it should
Okay.
be kept in
Yeah.
the central header for potential future use.
Right, out value result. This out value result apparently is only used in numeric right now. We could put it in numeric instead of putting it in X utility. I'm tempted to leave it in X utility because that's where the majority, if not all, of the other algorithm result types are defined. Yeah, they did put this together with other algorithm result types in the header.
You might want to reshare your screen.
Thought I did, but apparently I didn't do it hard enough. There we go. It outlined. Okay. Tiny little throughput cost for one class template that's not instantiated. I don't see this being a huge throughput problem if we do leave it in X utility. So I'm not going to complain about it. But then again, I wouldn't refuse a change if somebody else said they wanted one either. So I'm just going to let that one go for now. And we're going to move on to more product code. We're going to go into numeric and take a look at iota. Okay, I need a little more context to see where we are in the header. We're right after stood iota. Excellent. That's where I would want this to be. Right off the bat, we're defining the alias for the result type. This again is also part of the convention used for ranges algorithms. We'll have a result type, and I'll call it a generic result type. Its name is exactly the same as the names of its members, member name, etc. _ result. And then we'll have a specific alias for each algorithm for the result type that it returns. Since this algorithm is named iota, we have iota _ result is an alias of out value result. And that again is exactly as specified in the paper. Moving on, this is internal machinery. I'd like to get down to see the actual user public declarations first, to ensure that they match the standard. Okay, we have input or output iterator, Sentinel for that input or output iterator, and weakly incrementable. Requires indirectly writable, first type, comma, const L value of third type. That agrees. Const expr, iota result, first parameter, third parameter, iota. This overload takes an iterator and a sentinel and another type initial value. So this does appear exactly like the declaration in the paper. And this next one also, incrementable output range, const L value of first parameter type, const expr returns an iota result of borrowed iterator R, comma T, borrowed iterator R, comma T, iota, forwarding reference to RNG, range type, and value. So these declarations do look exactly like they do in the paper, which means they are wrong. Yes, this is one of these weird things. We have front matter for ranges algorithms that specifies, let me get the standard open, which I lost somewhere here.
And while you find that, I'll read out Cameron's question. Cameron asks, I have a question unrelated to this specific PR, but rather to ranges as a whole. I noticed that some algorithms like for each are not available for ADL to find, that's argument dependent lookup, because they're implemented as an inline variable, but others like this iota are not. What is the motivation for one method versus the other?
What a strangely pertinent question. So the reason for the difference is that these in the PR are incorrect. We have front matter that states various requirements for overloads of algorithms in ranges. This is the right stuff. I will find parameters otherwise specified. There we go. The entity is defined as the stood ranges namespace. Let's make this bigger so that I'm not the only one who can see what I'm reading. Okay. We'll look at paragraph 2 here in algorithms.requirements. The entities defined in the stood ranges namespace in this clause are not found by argument dependent name lookup. When found by unqualified name lookup, or the postfix expression in a function call, basically unqualified lookup for a function call, they inhibit argument dependent lookup. This is an intentional bit of design weirdness where we had to introduce this property so that calls to ranges algorithms would be unambiguous, and they wouldn't be actually unambiguous isn't the problem. If you think about calling find, for example, the 2-iterator version of find in stood has a corresponding iterator sentinel implementation of find in ranges. And if you wanted to call find with 2 iterators, and those 2 were somehow in the same lookup set, you would end up calling the stood version instead of the ranges version because it is more specialized. Since stood find takes 2 first arguments by the same type, and the ranges one takes those 2 arguments could be different types, it is less specialized. Anyway, and in order to get around this problem, we decided to make the ranges things not findable by ADL and inhibit ADL when they are found otherwise, so that these calls will work. And of course, implementing that means we have to implement them currently as objects. It would be nice if C++ gave us a better tool so that we could go ahead and actually implement these things as function templates, but function templates that have the same property of inhibiting ADL or not being found by ADL. But that hasn't happened yet. There are proposals in the works in the standard, but none of them, to my knowledge, is actually progressing. So that's a thing. We have lots of things that are not really specified as objects, but are implemented as objects in the STL for ranges algorithms. They're often referred to colloquially as neebloids, thanks to Tim Song, who is a CPP reference maintainer and occasionally shows up at WG21. He came up with this name neebloids to basically mock Eric Niebler, since Eric wanted them to be objects, and I argued that we should probably force the language to make functions work so that libraries could use functions instead of having to have everything be an object. But anyway, until that day comes, that means these things have to be implemented as sort of object-likes. We have a convenient pattern we use for that in the STL already. I'll go into algorithm here.
While you're looking that up, I have a question. So in the standard, there's been some movement towards trying to name things by what they are rather than after people, because the people-based names are confusing. Like argument-dependent lookup occasionally used to be called Koenig lookup after Andrew Koenig, who was the one who specified it. But Koenig lookup tells you nothing unless you know who he was and what he did. And argument-dependent lookup at least says what it does. With neebloids, is there a formal term that we should be using? I know that customization point object is related but different, and I can never remember
It's very much
if
different.
yeah.
And people get the two things mixed up all the time because one of them has a name and the other one doesn't, and because we added both things in ranges at the same time to the standard. So a customization point object is something that is explicitly an object, right? It's callable. It's a function object type, but it is definitely an object. You're allowed to treat it like an object, which means you can pass them around as arguments to things that take function object arguments, which of course is extremely handy and would be really handy to have for the rest of these algorithms. But again, since I would like the core language to be usable by people who write libraries, I would like if we had first class overload sets or overloads of function templates. And we didn't need to we didn't have to artificially force things to be objects so that they would be useful. So it would probably be nice if we had a name for this thing, especially if it's going to stick around for much longer. I think maybe in 1 or 2 more cycles of the standard at most, we'll either have changes in the core language that let us call these things actual function templates, but function templates with an attribute on them that gives them the right semantics, or we'll have given up and these will become actual explicit objects, in which case they'll just be CPOs like the other CPOs. And we won't need a name for nibloids. Anyway, the intended transient nature is why we never had a name for it in the first place. We just let them be things, and somebody had to decided to come up with a name to document them, right? Tim I said he was a CPP reference maintainer. He came up with a name to be able to document these things as a class.
Thanks. That explains a lot. And I've been reviewing this for a couple of years now, and I didn't know the whole story.
Well, now you do.
I also have a question about these things,
Shoot.
which might be unrelated. And if it is, we can talk about it later. But how do you get a function pointer to these things? Because I don't see in the standard that you can't take a function pointer to these things. But I don't see how it's implemented to take a function pointer.
Sorry, it's not implemented because you're not allowed to take the address of things in namespace stood, except when explicitly allowed.
Ah, fair enough.
Another one of the changes that came through in C++20. Yeah, we have algorithm requirements and or blanket requirements that have just enough magic to let you implement these things as functions. As objects, despite them being depicted as function templates in the IS.
Cool.
We have wording. For example, we have wording that says you can't pass explicit template argument lists to these because that would break if it was an object and not actually a template. Anyway, there were.
And it's worth noting. It's worth noting that users taking the address of standard library functions or passing explicit template arguments to them was problematic even before these object imitators were added. For example, people doing that with std make pair back in C +9803 were broken when the signature of make pair changed in C +11 to be perfect forwarding. It would create a totally, undesirable template specialization. If you said make pair angle bracket, int comma double, you would now get int ref comma double ref as your function parameters, and that is not something that code written in C +9803 was expecting. So it had always been problematic, and with the addition of these object-like things, the standard flatly forbidding users from doing this unless otherwise specified has solved both those problems and more.
Yes, and forbidding taking the address has also conveniently allowed us to make some more optimizations to the STL that we couldn't do otherwise. Sorry, Nicole, I think I interrupted you.
Oh, I was just saying thank you for the explanation. Yeah,
that's what this process is all about. So anyway, here's an example of find first of, the implementation of the find first of algorithm. it is defined as a class object. And we have a helper called not quite object that we derive these from, whose purpose is to make impossible some of the behaviors that you would expect to work with this if it was supposed to be an object, to keep people from accidentally taking advantage of what's effectively implementation details. So not quite object. Let's go find that. It's got to be an X utility, right? Ta-da, here we go. Not quite object. Actually describes what its purpose is, because this is a really weird thing. It has a deleted default constructor to keep you from constructing objects of this type without knowing the magic construct tag, for example, right? We have a secret tag type that's necessary to construct these. They're not copyable or movable. We've even deleted the address of operator. You can't try and take the address of it like it's an object. But protected default, protected destructor. Always a nice thing with base class to have either a virtual or a protected destructor to keep people from destroying through pointers to base with undefined behavior. So this is designed to be a base class, and it inhibits lots of otherwise useful things that you would want to have your objects to have if they were intentionally objects. So these two template overloads of iota, there are only two, right? Yes. Ditto Neebloid. Sorry, I'm scanning the existing comments. It looks like we actually have an attempt. Let's clarify this a little bit. Clarifying the algorithms.
I think, did you look at Misko's first comment? Because I think in his first comment, he did at least try to explain what Neebloids are. This is the second occurrence. That's why he just said ditto.
Yes, I get that. And let's just search for Neebloid. This is unfortunately ranges. Algorithms are not functions or function templates, but are currently implemented as Neebloids. Those are objects with a call operator. The reason for that is that it inhibits ADL. Close enough. There are some conventions to follow here, and you should have a look at how the other ranges algorithms are implemented. The general starting point is something like class algorithm name underscore fun. Yes, this is how we name them all consistently. Name underscore fun. Inherit privately from not quite object. Make its constructor set available with a using declaration. And then implement overloads of the function call operator to implement your actual algorithm. Declare an inline variable object of that type, right, the type of your function object, and initialize it with not quite object secret construct tag. So, boom. This is a great comment. I think he actually did a pretty good job of explaining what to do here. Yeah. Which
I just wanted to save you the work of writing all that again from scratch.
Yeah. Yeah, Misko has implemented quite a few ranges algorithms in his time, so I'm not at all surprised that he knows how to do it correctly. Anyway, that's awesome. Yeah, it's fun having a community around the STL to do our work for us. All right, coming back here. So that's already clear, right? Ditto Neebloid, presumably they will understand if they read Misko's comments in order what that is trying to tell them. So we will go ahead and review the algorithm. see what the paper had to say. Paper which I've lost track of. Add the following to iota effects equivalent to. Well, first is not equal to last. Well, first not equal to last. Star first equals as const value. We are as constant the value to enforce that value doesn't get modified, which I don't think stood iota does, but hey, that's okay. It's still pretty close. We increment the iterator, we increment the value, loop on around until we get to the end of the range, and then we return the final value of the iterator and the final value of the object that we're using to initialize things. Pick a name. Accumulator would be the name if it was stood accumulate, but it isn't. So accumulator is nevertheless what it's doing. And let's go see what the actual implementation does. This is going to be hard to read. It's a shame there's no way to collapse comments on GitHub. That would be really nice. Anyway, let's look at the iterator sentinel overload first. We've already checked that the signature is correct. The first step is to verify the iterator sentinel range using our iterator checking machinery. Right, we have this is a standard ADL verify range, does a lookup to figure out if these iterators are iterator and sentinel type are opting into our iterator checking machinery, and if so, it does any checking necessary, after which it's safe for us to unwrap the iterator types into an unchecked type. So lets the STL use checked iterators and still it allows the STL to use checked iterators in APIs so that we can ensure users are using the iterators correctly, and then unwrap them and have fast unchecked iterators that we use internally for the actual implementations of algorithms. In any case, we're verifying the range, and then we're going to unwrap both first and last. Since this is potentially an input iterator, yeah, this is potentially a single pass iterator. We have to pass in our value to get unwrapped, since input iterators may have things that need to be moved. So we unwrap an R value, we unwrap an L value of the sentinel. We'll pass all of this to the helper iota unchecked, which is a common name that we use for helpers that implement the algorithm after the unwrapping. Right, they're using unchecked iterators instead of checked iterators. And iota unchecked is up here. It takes an iterator, constant reference to the sentinel instead of taking the sentinel by value. That's kind of odd. There's already a comment here on the thing that I'm calling out as being kind of odd. Oh no, this is a different thing. Sorry. Misco's comment suggesting that we can take val by const reference instead of by mutable reference, which doesn't work. As Stefan has already pointed out here. I'm going to go ahead and resolve this comment. Just to draw attention to the fact that there's no action to be taken here. So the author of the PR can read the comments if they like to, but they will hopefully know that they don't need to do anything there. Moving on, here's the body. We're using a for loop instead of a while loop. First not equal to last, increment first, increment val. It's got the mandatory void cast here, which hopefully keeps overloaded comma operators from being called. As always in the STL, we have to defend against hijacking of operators that we use by strange ADL overloads. Right, this algorithm is not specified as calling a comma operator with an iterator and this whatever object type that we're passed in. So we can't observably call that operator. We have to make sure that it's not observable by user, and we do that by basically ensuring that no IDEO lookup will find an operator comma and invoke it. The built-in operator comma. All right, then we've got star first equals constcast. This is a handy way of implementing as const directly instead of calling as const.
I would make the argument here that it should probably use static cast. Because
so would I.
Yeah, we're not casting away const, so in my opinion, should use static cast.
We have the suggestion to actually call stood as const instead. I don't think that's a great idea either. I think we can get away with a static cast here.
And I have offered a third alternative. Because, and yeah, you can read my comment there. Static cast is powerful in a different way. It can't remove constness, but it's willing to, make temporaries and that sort of thing. Or maybe not temporaries, but it's willing to do fairly powerful transformations. Here we want something that happens implicitly. So if we're willing to spend an extra line, we could just implicitly bind a const ref. I think that would probably be safer than a cast, or at least less scary looking.
Interesting.
Yeah, because the thing about static cast is it's willing to reverse implicit conversions, which is actually what we don't want here. We want the forward implicit conversion of adding constness, but there's no like super safe static cast that'll do just that. So that's why I suggest just make a temporary variable or a local variable.
I wouldn't say no to this. I wouldn't write this. I would write it to I would write the static cast. I wonder why it matters to me. It's interesting. I would write the static cast probably because this consumes an extra line. There's another name to reason about. We avoid that with the cast. It is unfortunate that there's no clean cast that just says add const to this, other than the one, of course, that we define in the standard library, which requires instantiating a function template and suffers a throughput cost. So yeah, I'm happy with this. I'm not going to add another comment here, just to be clear.
One thing I'll say is something that is confusing to me is why we are not okay with as const, but are okay with move. Because that seems odd to me.
We're not really okay with move either.
Yeah, you got to. That's it's an excellent point. Like we do spend move. Oh, sorry. Go ahead.
The cognitive overhead of implementing move directly is high. That's really the issue. It's much more readable to see stood move blah than it is to see static cast x ref blah and then have to go back and determine, okay, is x actually the type of blah? Is this a move, or is it forward, or is it doing something else? And in that sense, having the actual names move and forward as vocabularies is nice for readers.
Fair enough.
That said, there is a throughput cost, and it would be nice if we didn't have to pay the throughput cost. I know I could be convinced that we should have forward and move macros. Even though I despise macros, I could be talked into it as a way to improve throughput. If
I would be interested in the amount of actual speed you'd get from switching to move and forward macros. Especially since move, I think you still need to instantiate remove ref t, which is a template. I don't know. Anyway, beside the point.
And we have active conversations with the front end team about making at least forward and move compiler known so that it can just directly transform them without emitting real function calls. For reference, Clang and I believe GCC have already done so. And MSVC does similar things to things like remove CVT, just not moving forward. So that's that would be my preference compared to macros. And honestly, I mean, now looking at my comment here, it sounds like I'm advocating that we shouldn't use as const. I'm actually fine with as const here. I mean, it is one call per element, which is a little bit more expensive than one call per outer call to the function. I had just recommended, we could use a local variable here in case, throughput was a concern, because I know that I personally have been relatively unconcerned about debug performance over the years, and I should probably care a little bit more. And this seemed like a reasonably cheap way to do so that didn't involve like obnoxious static cast tref or anything, but I would be fine with asconst myself.
Also, this is totally gross and I hate it, but you could put the const tyref const val equals val above the loop.
Yeah.
Which would result.
Oh, and keep it bound even though the value changes.
Yeah.
Yeah, that it still spends a line. I don't think it would necessarily interfere with compiler optimizations, but it is weirder to reason about.
It would be a line you wouldn't have to skip over every time you're going through the loop in single step mode.
Okay. True. There would be that improvement. Yeah.
A little bit of UX for people debugging through this, but yeah, we can argue there's lots of reasons, lots of little reasons to prefer one thing or another thing. I don't think any of them is actually the best suggestion. Sorry, I don't think any of them is clearly better than the others, except of course getting rid of constcast. I think we all agree that we don't like the constcast.
No constcast everywhere, please God.
Well, we do have some constcasts in the code base, I believe, but keeping them to where they're necessary is like really unavoidable is ideal, because that way we can focus all of our attention on them and say, okay, we're doing something super scary here. Let's make really sure that this is the right thing to do, which is generally true for cast, but especially for constcast.
It really seems like we should have this like unsafe keyword maybe that puts all of our focus on unsafety into like one area maybe.
We already have one. We have a lot of them in C++. we have as many unsafe keywords as you like in C++. That's one advantage it has over Rust. Advantage. Okay. Moving on. I think we've beaten this point into the ground. We've got this loop. We're happy that the loop is correct. We don't like the constcast. We've made recommendations about putting something different there. I don't think we need this move. First is the name of a variable with automatic storage duration. Right? Doesn't that mean
that gets
get the magic R value treatment in return, right?
They added that though after 11. I think that's why I missed it, because in 11 original, the function parameters I think were not eligible for auto moving, and that did change at some point. All the standard versions blur together for me now.
Right, because function parameters cannot be like nervoed. Like they can't be like done without
they can't be RVOs. Call. You can't do return value optimization because the parameter has to get stored where parameters go. It can't get stored where the return value goes. But nevertheless, I think the implicit move rule works here, so we don't really need this move.
Yeah, and I think Nicole was correct to say nervo specifically, because it is a named parameter.
Although now return value optimization is not a thing in C++ because PR values are actually a real thing. I'm so happy they finally fixed that.
There we go. Class.copy.revision 1.1. Who is extraneous?
Looking at this makes me wonder if this is potentially a global problem throughout the code base, like if we're redundantly moving parameters that are non-CV qualified. I bet you
might-
there's other occurrences. Not that we would ask this contributor to go clean up things globally. If anything, it should be a separate PR.
We should do a global cleanup of this. I'm not terribly concerned because it's not really a throughput issue. Right? Redundant move is only a problem when it inhibits Nervo.
Oh, that's right. Yeah, yeah.
And Nervo can't
so at
happen
most
here.
it's in the extra call.
So it's just extra words to look at.
Yeah.
I believe that this should be paragraph 3. Paragraph 1.1 is about named return value optimization. So in a return statement, when the expression is the name of a non-volatile object with automatic storage duration other than a function parameter, the copy move operation can be omitted.
Throw, coroutine, exception declaration. And implicitly movable entity, this wording got changed recently for 23. More things became implicitly movable. Automatic storage duration that's non-volatile or non-volatile reference to a non-volatile object type. Okay. So they haven't broken this wording. It's still 3 and 3.1 specifically.
And I do recommend citing a working paper number when you cite a paragraph, particularly when they are editing the standardese. Those paragraph numbers can be moved around, as we've seen here. So saying like N4910, if that's the latest one, could be helpful if we got to go look this up, in 5 years and wonder, wait, what were we citing? What paragraph was this?
Should this use Tim Song CPPWP so that it's stable?
That's a really good idea. Don't remember. What, no 4910? Let's hack the URL.
I did see a tip of trunk, but I don't know which that corresponds to. I haven't used this myself. I was just proposing citing the actual just name to say 4910 and let them look it up necessary, because I was mostly concerned about us looking at this comment.
Yeah, the problem with
years down
4910
the
is
road.
that I now have to go look at 4910. Because I never use the working draft. I always use my own copy that I regenerate every day. All right, where were we? Class dot copy. All right, there we go. It's paragraph 3 in N4868. It probably also is in N4910.
Yeah, as long as it hasn't changed recently. Most time I was just suggesting citing a specific draft so that if we ever needed to look this up later, we could find exactly which paragraph we meant.
I'm confusing myself. First is all right, moving on. Next overload. No, this is the overload we're working on still. Sorry. This again returns the final value of the iterator from the loop. we don't need to return the final value of val because we're using an L value that references the original value of val in the caller. Ta-da! There. So we get first back from this iota unchecked call. It's an R value, so we don't need to move it. We wrap it back up inside the original iterator, which we then return in our out result, or our iota result, IT comma tie. We're returning the result of moving first and tie. And the paper did want us to move tie, didn't it? Return move first, move value. The other overload for ranges. This takes an iota, it takes a range, and a tie. There's not going to be any wording for this in the paper or in the working draft, because again, we're lazy and we like to have magical blanket wording that means we don't have to repeat things over and over. So we have magic wording in the algorithms requirements again that say that range algorithms to take a range are equivalent to taking the result of calling begin and end on the range and passing it to the iterator sentinel overload. So now we'll look at this and make sure that that's what it does. Luckily, we don't need any kind of verification. It's the major advantage. One of the many advantages of ranges is that they are correct by construction, right? Somebody passed in a range, we don't need to worry about mismatching begin and end units indicating where that range lies. We get it straight out of the range itself. So we're pulling first out of that range with ranges begin. Okay, yep. Pulling out first, and then we're going to call the same iota unchecked with the result of unwrapping first and calling to the uend range. Uend is a magic accessor that basically does the unwrapping for us of getting the end of the range. It's sometimes more efficient if for range types that are implemented specifically to have access to an unchecked end, which is a thing in our design. This will grab it directly instead of calling end and then unwrapping the iterator. It may be more efficient. So we're taking those, we're passing 3 arguments to iota unchecked, which does what we already know that it does. It returns the final value of first, which we wrap back up in the iterator that we have, and we return move first, move out, just as we did on the other overload. So this is correct. It can be implemented a little more efficiently using a rewrap iterator. We have a helper. Lots and lots of helpers. This one's probably an xutil. Yes. Wrap.
You got to turn off related matches. It is the dumbest feature.
That's not useful.
So frustrating.
I guess if you don't remember what you're looking for, it could be handy. You know, if I know it's something like this, then I might use that tool. But when I know exactly what I'm looking for, there. Anyway, we have a utility called rewrap iterator that takes a range and an unwrapped iterator, and it will either, sorry, if the unwrapped iterator type is the same as the wrapped iterator type, that's what this is trying to say, right? If this unwrapped iterator type IT is the same as the actual iterator type of the range, then we don't need to do anything funny in rewrap. We just return it. If the unwrapped and wrapped types are different, this meaning this is a range that has checked iterators, then we'll go ahead and grab a new begin from the range, and we'll wrap up our unwrapped iterator inside that and return it. This is constrained to only work with forward ranges by necessity, because you're only allowed to call begin once on a single pass range. Like calling begin on an input range or an output range can suck the magic smoke out of it and make you unable to call begin on that again. Since this takes an output range, it may be single pass. And that means we can't really use rewrap iterator. We don't have any facility for dealing with that, unfortunately.
So if we tried to, it would fail to compile, but only if our test coverage calls it with an actual output only range. Is that correct?
Yes.
Okay.
Yeah, it will fail to compile, but only when called with a sub forward single pass range. And
to check my understanding, because I actually hadn't looked into this comment here. I was like, oh, rewrap iterator, that sounds good, because I hadn't used it myself. Even in the case where we do have like a strong, forward range, in this code, we need to start off by calling ranges begin and then unwrap it. I guess we could call you begin, I suppose. Yeah.
Typically, that's what we would do. We would call you begin.
I see, you begin, okay.
Calling iota checked right into range wrap, with the idea that it doesn't necessarily even need to keep first around if they're the same iterator types, for example.
So. Is this not a use after move? I guess it's not. I guess first is
technically it is a use after move, yes.
Okay, but are we like asserting that this must be okay for anything that deals with our
use after move?
Okay.
It's part of the design of the iterator unwrapping design that seek wrapped can have a move from input iterator.
Okay, cool.
Okay.
Yeah, essentially the wrap state has not been changed. The pointer to the parent, but the pointer to the element is what's getting totally reset here. Most I was wondering, like, I see what that would do for like a forward list or a stood list. For vector, though, it seems like we would actually be calling begin twice. Oh no, not if we called you begin to begin with. We would at most have one begin. Okay, never mind. Only the single pass thing is preventing this from being desirable.
Obviously, you could sandwich something together with if const per here, but it's probably more trouble than it's worth. We're talking about a pretty minimal benefit in the first place. Let's go ahead and say I don't think it's worth to if const per the forward and sub. Oh, separately. I don't know how to spell that word. I leave this as is. Oh no. Somebody say something. Am I dropping again?
No, you're fine. Okay. It just looked like GitHub took a little second to respond there, possibly because you just pushed a comment with a typo. Oh no.
Because what? I pushed a comment with a typo?
Yeah, you're separately. You didn't fix it before submitting. It's like my eyebrows twitching. I'm like, no, never mind. It doesn't matter.
I spelled concept correctly. Okay.
Yeah, separately should be a keyword if it wants to be spelled correctly.
And it took 3 seconds, and I realized nobody had said anything for 10 seconds, and thought that it was disconnecting again. Anyway. Okay, let's take deep breaths. Everything's fine. We are through iota. I should verify this new end if comment matches an if comment. If has 23 and CPP lib concepts is defined. Yes, that's also correct because this is a C++23 edition. And we don't want to define that code and or test it when we're running EDG in the test suite, because EDG concept support is still not quite ready for the STL, although it works well enough that it's been enabled in IntelliSense. So IntelliSense does see all the concepts code in the STL. Okay, moving on to algorithm. Sengard, which is again right for the same reasons. Okay, let's slide down to again the public interface definitions. We've got the neighborhood comment. You'll recall, so we don't need to worry about that. Where did the paper go? Shift left and shift right. Oh, this is weird. Whatever we used to write the paper has kept the enormous margins on my narrow window, which makes it pretty hard to read. Anyway, this is a template. It takes first argument must satisfy permutable, and the second must be a sentinel for the first, which is exactly what this says. Const expr returning a subrange of the first parameter. Shift right. First template parameter named first. Second template parameter named last. And iter difference t of the iterator type. All right. This person is using iter diff t, which is an internal thing we had even before it was added in C++20 that does effectively the same thing, but by going through iterator traits in C++20 mode and by going through the actual iter difference t alias in C++20 mode. I think if I recall, let's go ahead, already commented on that, but I don't see it. Is this above? Yes. Misco commented the first occurrence, and Stefan pointed out that there were several. So this is already taken care of. All right. Somebody already caught the iter difference t issue. I won't comment on it again. That probably came from copying our C++17 implementations of these algorithms in the first place. At least that name pause to shift seems really familiar to me. So
I'm glad that Misco caught it, because I probably would have missed that one. I do know enough about like remove CVT that if I see the ugly one being used in modern code, I'm like, oh, we can unconditionally use the modern one. But
right.
with iterative T, I think if Misco hadn't noticed, I probably would have said, yeah, I know what that does. That looks right. And wouldn't have realized, oh, we should just unconditionally use the standard one there. So I'm very glad he noticed it.
It's correct, right? It would have been correct. Again, it does the same thing in C++20 mode. It's just a readability problem only. Anyway, let's look at the other template. Forward range requires that the iterator type is permutable. We're returning a borrowed subrange of that range. Shift left. Takes the range argument by forwarding reference. And it also takes a range difference t, which is spelled correctly here because we don't have another version of that. And the same function parameter name, positive shift. So let's go ahead and look at what these are doing. This looks strangely similar to the iota thing in that it's checking the range, right? Doing the validation first of the range, and then auto result equals first. I'm sure that should mean something to me. Let's go back and find this. Okay, preconditions. N greater than 0 is true. Effects. If n is 0 or n is greater than or equal to last minus first, right? If n is greater than the number of elements in the range, is what that means. It does nothing. Return defines something called new last. We return a first comma new last for the overloads and namespace ranges. So we need to make sure that this is the unmodified first argument. Okay. And we do that by making a copy. To rewrap. All right, this is clear to me. We're making a copy of first. We're unwrapping. There's no move here, so let's make sure this is, yeah, permutable refines forward. So it's okay that we're not moving first when we pass it to get unwrapped, which should leave it unmodified. And we're going to wrap the return value in this copy we've made called result. So hopefully the return value from shift left unchecked is going to be this new last that the paper says it's calculating, which is the, well, whatever the pointer, sorry, the iterator after the final element that contains a value that was in the original range. Right, we're going to ignore the tail of elements after that that are going to be moved from when we shift all the elements to the left. So we checked this already, right? It's unwrapping first, unwrapping last, and passing pause to shift left unchecked. Let's go take a look at that unchecked algorithm, which I'm certain was defined above here. Because that again is our style. Yeah, it takes an iterator and a sentinel, returns the iterator type, doesn't need to modify the sentinel. Again, this needs to be iter difference t. And its behavior is, if we're shifting by less than 0, we advance first to the end of the range, the original range, and return it. And that is going to be first plus the original number of elements in the range minus 0, right? If it is 0, then it's number of elements minus 0. So new last will actually be the iterator that corresponds to the sentinel last. And that's what we're doing. We're advancing first until it's equivalent to last, and we're returning it. Otherwise, we want to start at first. I believe it only equals 0. This is interesting. I think I thought there was a change to allow negative n with no effect. Or maybe the paper, sorry, maybe shift left originally allowed negative n with no effect. And the change was to make it a precondition. Let me go look at what the standard says. Or the existing shift left, the C++17 shift left algorithms. Yep, precondition. So this was not an error in the context cited in the paper. That's what the paper says. So yeah, that must have originally allowed in negative values, and it was later changed by an LWG issue. And I've got the order mixed up in my memory. All right, I won't argue with Stefan's comment. This is reasonable. If anything, if we do, and I agree we should, the assertion should shift left itself should be in the caller instead of in this helper function. Easier for users if we report errors inside something with a name that they called in their code, which is probably obvious to Stefan and obvious to me, but may not be obvious to the person that wrote this. So we'll include that comment.
We would need two assertions, right, for the iterator sentinel and the ranges form, I think. Is that right?
Yes.
Did we do that elsewhere where we repeat the assertions in each public entry rather than centralize? Or has it not just come up enough that we've got preconditions?
I think we usually do that, yes. We usually apply preconditions as close as we can to users.
Okay, I couldn't remember what we do.
If we don't, we should fix it.
I think we may have some cases where we do centralize, but we're careful that the I think I recall the message will sometimes mention the standard pretty name rather than the underscore ugly name and say ranges : shift left requires blah, even if it's being emitted within the internal helper. But I would need to go check to see what the actual precedent is.
I believe we should not do anything here except checking this. I can't see the code. Can't see the forest for the trees. Okay. We make a copy of first. If we have a size sentinel, we check that positive shift, if positive shift is greater than the, again, the entire length of the input range. And if so, we return first, which is correct. Now, new last would be, I lost the definition. Am I still looking at shift left? No, I'm looking at shift right. All right, new last is first plus the number of elements in the range minus ends. Okay, except n caps, effectively, at last minus first. So if n is larger than last minus first, then we return the new last is just first, which would be the result of doing all this math if this was max of n and last minus first. Okay, so that's correct. If it's size level 4, if it's not greater, we advance start at by pause to shift. We skip over. We take this copy of first and we skip over the first n elements. Now that we know that n is somewhere within the range. This is going to give us a copy from point, right? We're going to end up copying from here into first later on. Okay, otherwise, if we don't have a size sentinel, we're going to index our way into the range manually instead of calling advance. Decrement pause to shift, and for each decrement, we'll increment start at, but not if it's already at the end of the range. If it has hit the end of the range, we return first, which we already decided was the right thing, right? If the shift count was greater than the length of the range, this should return first. This is just another way to do it. Yeah, we try to avoid iota conditionals. And oh, I've afflicted Misco with my hatred of multiple blank lines. Oh no, he just doesn't like this blank line in between the if context and the definition of the variable. I believe we should not do anything here except checking the distance by range's distance. If the difference is less than 0, it's less than 0, we have a problem. If it's 0, this does nothing. Suggestion for familiar side is yourself with debugger errors. Usually we use an internal helper function for both implementations without the balance checks. But here the implementation might be simple enough to do it in line. All right, I'm not sure entirely what he's talking about. I do see I'm wondering if we could use the 3-argument form of ranges advance here. There's a form of ranges advance that takes an iterator, a count, and a sentinel. That tries to advance the iterator, count steps, and stops if it reaches sentinel before going count steps. I think that's how I would do this. Because I could get
I wonder if it.
Yes.
I wonder if it would result in the same behavior when you do reach that last, because here it looks like we need to return the first iterator if the user has asked for an unreasonably large pause to shift. But if we use the 3arg clamped version of ranges advance, I think we might not end up returning first. I could be wrong, though. I haven't traced through all the logic. And with the Misko's suggestion to use move unchecked, I also am not sure exactly what it means now that you've pointed it out.
Yeah.
Because there's no like move unchecked n. We're trying to find the specific iterator in the middle.
Move unchecked.
Yeah, we do call it there. So I'm not sure what the suggestion is. Oh, and time check, it has been 1 hour and 31 minutes.
Oh, we're at time check already? Oh, this is so much fun. Okay. The nice thing about the 3-argument ranges advance is it returns any count that's left over. So if there's a non-zero, if it returns non-zero, we could return first as we're advancing whatever it is, start at. We would advance start at by positive shift towards last. So it would work here. I don't know if it's better or not without thinking about it. And we've run out of time for thinking about it, unfortunately. So why don't we go ahead and knock off here? Yeah, it'll take at least another 15 minutes to finish shift left. So we're going to go ahead and stop. Apologize for starting a little bit late. We might have been able to get to the end of it if we had that 5 minutes back. I'm sorry, I haven't used this particular machine. I haven't driven here before, so I wasn't set up and prepared. But anyway, let's go to questions. Are there any questions in the chat? Has everybody been asking?
No outstanding questions. Just some talk about why are we using those Nibloids and the stood move optimization. So you'd already covered everything.
Oh, there's a suggestion from Cameron that we assign our suggestion to him to implement move compiler front end. Anyway, okay. Thank you all for coming. And I actually like the live question format better than having people type things in chat and having to go back and get them later. That worked well. Anyhow, thanks. I will stop the recording now.